All right, here's an example of Hess's law problem. Just like we talked about in class, what we've got is we've got a equation that we're trying to figure out the delta H for, the change in enthalpy for the reaction. We've got a series of steps, 1, 2, 3, a series of steps that the reaction takes place in, and we've got individual delta H's for each one of those steps. What we want to do is take the steps and manipulate them, add them up in a way to come up with our final equation. And whatever we do to the equations, we do to the corresponding delta H's and add those up, and we come up with the delta H for the final reaction. Something that I made an analogy for was putting together a puzzle. We've got the picture on the box, and we've got our puzzle pieces. And what we want to do is try to put the pieces together in a way to come up with the picture on the box. So what I'm going to do is I'm going to take a look for something in the equation here and match it up with something in my puzzle pieces. What I see right here is I've got CH4, I've got CH4 both on the left side. So this is probably going to be the first puzzle piece I use, but I can't use it as is. It's a match, but it's a close match. I've got a 2 here, I've got a 1 here. So what I'm going to do is I'm going to take this equation and I'm going to double it. So I'm going to times 2 on the first equation, and what I'll come up with is 2CH4 plus 2 waters. I'm distributing that. 2 moles of water is going to produce 2 moles of carbon monoxide plus 6 moles of hydrogen. So I've doubled the equation. The next thing I'm going to do is try to find another puzzle piece that fits, and I'm looking around and I see this here, CH3OH, and I see this here. Again, it's a match, it's a close match. I've got 2 here, I've only got 1 here, so again I'm going to double this equation. So this is going to get doubled also, and what I'm going to wind up with is 4H2 plus 2CO, carbon monoxide, is going to produce, it's going to produce 2 methyl, I think it's methyl alcohol, CH3OH. Again, I've distributed that too. All right, so the last thing I've got is I've got one more puzzle piece to use. Again, that was the other thing. I can only use each puzzle piece once. So I've got another puzzle piece here. I see I've got oxygen here, and I've got oxygen here. It's an exact match. Everything is on the proper side. I can go ahead and use that as is. So I'm just going to recopy that as 2H2 plus O2, oxygen, produces 2 waters. All right, so I've got that as is. And at this point, what I'm going to do is I'm going to total these guys up. By totaling them up, it's kind of like with a system of equations in algebra. I've got things on both sides of my equal sign, so the things on the both sides, things on opposite sides of the equal sign I can eliminate, I can cross out, because I would eventually wind up subtracting from both sides. So things I can get rid of, things on both sides of the equation, I've got 2 waters over here, I've got 2 waters over here, they go away. I've got 4 hydrogens, so that takes this down to 2 hydrogens, but look at that, I've got another 2 hydrogens, that eliminates the rest of it. I've got 2 carbon monoxides here, I've got 2 carbon monoxides here. I've eliminated everything I possibly can, so now I'm left with this, and this on the left-hand side, and this on the right-hand side. So let me just bring all that down. I wind up with 2CH4 plus oxygen produces 2CH3OH. a match with my box picture. So it matches. So now I can go ahead and do the same thing to the delta H's that I did to the equations, and I can come up with my delta H for this overall reaction from this series of steps. So let's see here with the first delta H, I doubled it, so I'm going to go ahead and multiply that by 2. So I'm going to get 412.2 kilojoules. That's 2 times 206.1. I'm going to double the next one. It's 2 times a negative 128.33, which is equal to 256.66. 256.66. You know what? I'm going to double check that because I'm doing this in my head. So I got 2 times a negative 128.33. 256.66. Yeah, that's right. Okay. And that's kilojoules. And then the last one I'm using as is, and that's going to be as is. So I'm just going to go ahead and write down negative 483.64 kilojoules. So what I'm going to do is I'm going to go ahead and total up these delta H's, and I get 412.2. Oh, I almost lost my negative sign on that. This guy right here, this guy right here is a negative, set negative sign. Yeah, I had a feeling that was going to happen. Okay. 412.2 plus a negative 256.66 plus a negative 483.64. Hit enter. I get negative 328.1. So delta H for the overall reaction is a negative 328. Yeah, 328.1 kilojoules. So this is my answer. This is the delta H for this reaction. Again, what I did was I took my steps, added up the delta H's after I went ahead and manipulated them, and got the delta H for the overall reaction.